The non-recursive statistical model. This is a type of model in which you have two variables that affect each other at the same time or through the same process, also called reciprocal causation. For example, supply and demand. These are two factors that affect each other, and it's their interaction that produces the ultimate output of cost. The procedure that deals with non-recursive models is a two-stage least squares integrated procedure. But we're going to look at solving the non-recursive model using a normal or OLS linear regression, and then we're going to, so that you can see the internal mechanics, and then we're going to finish by using the two-stage least squares integrated methods, which is basically a lot faster. So let's go get our data set, the ICBP, International Crisis Behavior Project, which is ICBP SPSS. And so this data set it analyzes crises, and it's got a number of variables. And most of the variables are ordinal, but there's enough categories that they sort of can be interpreted as interval level. So here's our model of interest. So you can see we have violence and actors. And I'm not going to go through the operationalization of the individual variables. Those are in the notes, and it has great detail what each of the values are for these independent variables. But essentially, the level of violence in a crisis can often widen the war to include more actors in the form of spin-off crises. And these in turn increase the violence in the crisis, which draws in further actors. So you can see we have a self-reinforcing process here. So disentangling this mutual causation requires use of a two-stage least squares model, or we can model it as a recursive model in linear regression. So to isolate the non-recursive or reciprocal causation between the two endogenous variables, which are violence and actors, the two mutually causing dependent variables, we need to isolate their relative effects with antecedent exogenous variables, which are called instrumental variables. And so we need two separate models that have an effect on those dependent variables. So we're not really accounting for mutual causation. What these procedures do is disentangle mutual causation so that we can independently describe the effects on each of the individual dependent variables and use sufficiently to be able to make predictions. Now this data set is over the period of 1929 to 1985, and it's got 323 cases. Okay, and so you have manage, which is whether there's a degree of crisis management. The intensity is the behavior by the most aggressive crisis actor. Geopolitics is how important the crisis is in terms of different regions of the globe. Soviet effect is whether the Soviets are directly involved. And abate is whether Soviet participation created a crisis abatement effect. Now, two-stage least squares, as well as the non-recursive modeling in linear regression, follow all of the same diagnostics that you have with linear regression. There's nothing different. We're not going to repeat those here because they're exhaustively explained in the linear regression procedure, so just follow those procedures. There is no skewness or kurtosis in the first diagnostic in any of the independent variables. There is no multiclinearity at all between any of the independent variables, although there is a close relationship between Soviet effect and abate. And the relationship is 0.734, but that's still less, but of course very close to the threshold of 0.75. Scatter plots were done to show that there is no curvilinear relationships, but there's a couple of close calls. I'm going to model one right here. So I'm going to graph through legacy dialog, scatter dot, down here to the simple scatter. We're going to model, now just so you know where all the independent variables are and the variables for this model, because they're to the right in the spreadsheet, they're going to be at the bottom of the dialog box for when we're selecting these. So in the y-axis, we're going to put violence, because violence is a dependent variable, and the x-axis is the independent variable, so we're going to put manage. And you're going to see that there is a bit of a curvilinear relationship. It's hard to see because they're defined by categories, and so the plots are pretty disparate, but you can see that we have sort of a U shape here. And so if we put a regression line down the center from left to right horizontally, it would underestimate low values and very high values of the categories in crisis management, and it would overestimate the values from 3 to 6, the central middle values for crisis management technique. So this would need to be solved. So let's go ahead and now run our models. Now the first step in ordinary least squares, running a non-recursive model, is to create proxies. So we're going to run a model with the endogenous dependent variable violence, its independent exogenous variables, which are manage and intense, basically its independent variables, and the independent exogenous variables for the other endogenous dependent variable. Okay, and we're going to save the result as unstandardized predicted values, which are going to come up as PRE_1 in the spreadsheet. So let's just go ahead with that. We go to Analyze, Regression, Linear. We're going to put violence as the dependent variable. We're going to put in all of the key variables: manage, intense, geopolitics, Soviet effect, and abate. So we're using both the independent variables for the dependent variable as well as the independent variables for the other dependent variable. Okay, now we don't need any of the other diagnostics. What we do need is to save the unstandardized predicted values. It's the only thing we're doing here because we're not doing diagnostics. So let's run it. Now if we go to the data sheet, we're going to see at the very end we've generated a new variable, which is the predicted values unstandardized. Right? It's raw. It's not been converted. So we're going to go to variable view and rename it. We need to rename this as a proxy variable, and we're going to call this variable violence proxy. Okay? And we can see it's been renamed here in the spreadsheet. Okay? So this is important. We're going to use this in the model for the other dependent variable. Okay? So let's go on and do the same for the other model. So here we're going to switch out violence. We're going to put in actors, which is the other dependent variable. We're going to leave in its own independent variables plus the independent variables for the other dependent variable. So geopolitics, Soviet effect, and abate, and manage and intense. And again, we are going to save the unstandardized predicted value. And it's going to come up as PRE_1 because we've changed the name of PRE_1 from the earlier model into violence proxy. So let's run this. And here again, if you look at the spreadsheet, we've got PRE1. We're going to rename this variable into actor proxy, or actor prox. Okay, we're going to need this for, again, the model that includes the other dependent variable. So here you can see violence prox and actor prox, and they've both been run. So now we're going to go ahead and run the two models. So we're going to run the two-stage least squares non-integrated, basically in ordinary least squares. So we're going to run a model with the endogenous dependent variable violence, its independent exogenous variables, and the other proxy variable. Okay, and we do that by going to Analyze, Regression, Linear. We're going to put violence in as the dependent variable. We're only going to put in manage and intense, its own independent variables, and we're going to include actor proxy, which is this new variable that we just created, which captures the effect on violence through the other exogenous variables. Now here we would make all the selections necessary for the post-regression diagnostics. We're not going to do that here because that's covered extensively in the ordinary least squares linear regression procedure. But if this was a time series, which it's not, it's a cross-sectional data. But if it was time series, you'd also have to run an auto-regression in addition to this, along with a Durbin-Watson to estimate the first-order serial correlation. So here, we're just going to run the model as it is. In fact, I'm going to turn off the unstandardized value here because it's going to add additional PRE_1s. So we click OK. And we can then take these values, the coefficients, and we can make prediction equations out of them. Right? So this is the first model, which includes the proxy. Right? This is the prediction equation with the constant and the coefficients times the independent variables. Now let's go run that for the second model. So analyze, regression, linear. Again, we're going to switch out violence for the other dependent variable, actors. We're going to remove all of these variables and include only those variables that are instrumental for actors. We're going to include violence proxy. And then we're going to include the variables of geopolitics, Soviet effect, and abate. And we're going to run this model, and it creates coefficients that we can then use to make predictions. And we have that here. So again, you've got a prediction equation from the coefficients. You've got, of course, the adjusted R squared and these other values, which show that this model is significant. Now, in the post-diagnostic steps, you would, of course, do all the normal steps that you would do in a linear regression. You would identify a significant, insignificant variables and exclude them. You would run for heteroscedasticity. If it was time series, you'd run a Durbin-Watson and run an autoregressive equation. So this concludes the manual way of generating a proxy and getting an accurate estimate of the effects on a dependent variable when you've got two dependent variables engaged in mutual causation. So let's take a look at the integrated two-stage least squares procedure, which is a lot faster. And I think you're going to understand it better because you've just generated a proxy variable. You're going to know that the proxy is generated automatically in the two-stage least squares procedure. So for the first model, we're going to run a model with the endogenous dependent variable violence, its independent exogenous variables, manage, intents, and actors, and all of the instrumental variables for both dependent variables. Okay? So we go to analyze, regression, and now we go down to two-stage least squares. Okay, I'm going to sort of lengthen this out here, bring it down. And so in the first model, we're going to put in our dependent variable of violence. We're going to insert only its own explanatory variables, which are manage, intents, and actors. Now we include actors because it is an independent variable. Now for instrumental, we're going to include all of the variables, but not the other dependent variable. So we're going to include geopolitics, Soviet effect, abate, as well as manage and intents. Okay? And we're going to run this. And you're going to see that the coefficients here are identical to the coefficients that appeared in the manual model, but this is a lot faster. All right, so here we have the regression equation. You can have a sample case values for the different variables, insert them, and then it'll produce this outcome, this prediction. Okay, and you're going to get the same similar with Model 2 when we ultimately run it. So let's go run it for Model 2. Here again we go to Analyze, Regression, two-stage least squares, and we're going to input actors as the dependent variable. We have to remove actors from here and then insert it here as the dependent variable. We're going to remove these independent variables and include the independent variables that are specific to this dependent variable, which is abate, Soviet effect, and geopolitics. And then we're going to run it. And here you get the accurate estimate, much faster, and it's identical to the values reported in the manual recursive model regression that we ran earlier. So this is two-stage least squares. It doesn't account in any special way for reciprocal causation. What it does is it decomposes the effects so we can get a more accurate account of what effect the independent variables have on a given dependent variable.